So, now we will discuss about the cloud deployment models. We have now talked about the essential characteristics. The next step is and the platforms. The third in that architecture, as I showed you in the earlier slide, is the deployment model. Now, there are 4 different deployment models: a public, private, community, hybrid. A public cloud is one infrastructure made available to the general public or a large industry group and is owned by an organization selling cloud services. So, everybody has to go to that public place and store data and do whatever you want. A private cloud is set up for one organization or a group of organization. It may be on your premises or it can be off your premises, and it is done only for exclusively for your organization, and nobody can share this. Okay. But it can be managed by a third party. A community cloud is only for one community. It is not for one organization, but for a community of organization. For example, it can be a mission driven problem or a policy or compliance considerations. There is a specific community that has some shared concerns, and so this will give that community a service, right. So, it is not for one organization, but it is for multiple but organizations which share some similar concerns, similar policies. So, we have a cloud that can basically deal with them, and again this can be on the premises of one of these community organization, or it can be off the premises. So, the next model is the hybrid model. Is a composition of 2 or more of these clouds that we have seen, the private, community or the public model. But what is so interesting about this hybrid hybrid cloud model is that they have some standardization that is based on the different organizations that partake here, but at the same time what is hybrid about this is how it is different from public. It gives you separate isolations even at the hardware level, but in case of need they can expand by doing what we call as cloud bursting for load balancing between the clouds. So, they can between 2 different sets of systems hardware, they have to ensure data and application portability, and they are also bound by proprietary and standardized technologies of individual organizations, but they can basically extend it across clouds by using these cloud bursting techniques. So, this is a notion of a hybrid cloud. Now, this is what you see in a private versus public cloud. This is what we call as the multi-tenant model. What is a multi-tenant? In the same server more than one customer can exist, right. Now, let us look at the private, which is on the left hand side. It is a private cloud. There are this is one organization which has 3 business units, and essentially you will have 3 servers, but you find that all 3 symmetric servers you will have, and you find that the business A needs more than one server, but not it needs 1.5 servers for getting the required service, for required performance and storage, etc. While business unit B needs only half a server, while business unit C needs one complete server. So, you have 3 servers now. Note that the business unit A and business unit B share one server, and there is one exclusive for business unit A and there is one exclusive for business unit C. Within the server you have something called a virtual machine monitor, which actually hosts several virtual machines. Each virtual machine can be a software in isolation which is used by the organization, or some sort of these virtual machines can also be divided based on some policies, right. So, the policy boundaries can basically dictate the virtual machines. Normally in today's infrastructure, each virtual machine will be its own, will be running one specific software. If you look at a banking, one will be running running the loan processing software, for example. Another can be running the email client, the third can be running some other fixed deposit software, the fourth can be running your NEFT software, etc. So, every virtual machine will be running a software. And why do you need a virtual machine? Because then the software, it gives you a feel to the software that the entire server belongs to the software. So, when somebody develops software, he can assume that the entire server would belong to him, and so essentially he is not talking about attacks or interactions of this software with anybody else, with another software. So, this virtual machine will give the VM that you see on the slide will give you a framework where the software each software can run within that blue box that you see captioned or labeled VM, and it will be running that software alone. But note that many softwares can run on a single server and each will have its own virtual machine. When you look at the public cloud, so there is a notion of multi-tenancy in the multi-tenants in the private cloud also, wherein more than one business unit can share the same server infrastructure, as you see business unit A and B sharing the middle server on your left hand side. On the right hand side you see a public cloud where many customers, you see customer A, B, many of them come in, and note that A and B share the same server. The physical hardware on which the softwares corresponding to customer A and the software corresponding to customer B run, they are the same server. In the same single server, your customer A and customer B runs their services. So, there are 5 different virtual machines as you see on the right hand side. Each virtual machine will give you a notion of isolation, will give a feel of isolation to the software that is installed in that virtual machine. So, this is the notion of a public cloud. So, what we see now here is the most important thing is that for me to have effective usage of the resource, effective utilization of the resource, we do the multi-tenant model, wherein more than one customer or software belonging to more than one customer or more than one software basically run concurrently on a single hardware platform, and each of these software will be isolated from all the others who are running on the same hardware by the notion of by the technology termed virtualization. So, this is how the private and public clouds are built today. We have seen about the definition of clouds and we have now seen about the architecture of clouds. Now, let us go and look at the benefits of cloud computing. What are the benefits of cloud computing? Again, we can classify these benefits as business benefits and technical benefits. We will now go and look at what are the business benefits and what are the technical benefits. The business benefits are 5 in number. I need not invest any money, I can just go and hire a cloud and it gives me all that I want, and I have to pay only monthly rent or monthly usage cost because the cloud is actually metered. So, almost zero upfront infrastructure investment. The second thing is I need not go and raise a purchase order, hire a building, hire a get network clearances, get access to those networks, buy all the hardware, nothing. All those are already provided by the cloud. So, it is a just in time infrastructure. Whenever I want, I can just start using the cloud. If I want to actually start my own data center of reasonably good capabilities, it requires at least 2 years of planning. So, if I want to start a data center say 2 years from now, I should start planning now, I mean from the stage of hiring a building, setting up all the necessary infrastructure, and I am looking also at a tier 1 type of data centers, is going to be a 2-year affair. So, the biggest benefit, that business benefit that a cloud infrastructure gives you is a just in time infrastructure and more efficient resource utilization. So, you are not paying for the actual resources, you are only paying for the metered. So, if the CPU is not assigned to me, I am not going to be paying that money. If it is not a cloud and you have dedicated services for each software, then if your CPU is not utilized, still you have already invested the money to buy that hardware and put in your data center. So, one important use of cloud is more efficient resource utilization, and you would have usage based costing. If I am not using, then I am not going to pay for it. And the most important thing is that once you go in for a cloud infrastructure, since many things are provided there, you can actually go to launch your product or anything that comes out of this cloud computing in a very reduced time. So, I can go and market my organization. I am starting business today, I can make the business, I can bring the business to the market within very short time if I start using this cloud infrastructure, because many things are maintained by them. Now, look at the technical benefits. One of the thing here is this automation, or what we call as a scriptable infrastructure. What is a scriptable infrastructure? I can go and pick and choose. What is a script? A script is one which can go and set several configuration parameters, it can pick parameters and choose, right. So, people who have done script level programming understands what a script does, but for people who have not done scripting, it does essentially means that we can go, depending upon the scenario, I can quickly go and set what parameters I need to access. And another important technical benefit of a cloud is auto scaling. You can just scale as and when it is needed, and it can also go and predict, hey, next month I have to, this server performance will go down because the data is increasing, so let me go and scale it this month itself. So, I could have a proactive scaling of servers, and it is a very efficient development life cycle. It can provide you a more efficient development life cycle, because there are lot of things that gets monitored and reported very quickly, and it gives you very improved testability, and because lot of things are already tested. If I look at a cloud, the platform, the infrastructure and the software, whatever, they are used by many customers, and so they would be tested. So, I need not go and test all these commonly available software and hardware, and the entire testing would be restricted to the software that is executing on the cloud. And so, this will improve, or anything specific that is going on the cloud, and this will certainly improve the testability. And the important thing is that this cloud is managed by a provider, cloud service provider. Please note that in many business, IT is a way of doing the business. IT by itself is not the business. If you take banking is your core business, IT is not your core business. If I am looking at markets today, the market is your core business. Developing software for that market is not your core business. So, when we look at business continuity and issues like disaster recovery, which are major technical benefits, what does business continuity mean? If I have continuous availability of the services, then my business continuity is very good. If it is going to stop, then that business continuity at even random times, then the business continuity does not exist. Similarly, when there is a disaster, how quickly can I recover and give the service? So, we are talking of this availability in security term when we talk about the last point in this slide. Now, since the cloud is maintained and it is tested by many users, and then they essentially have a large infrastructure, now your disaster recovery and business continuity, will be addressed automatically, right, and that is one major technical benefit. If you are a very small organization, you cannot afford to have your own cloud immediately. Rather than doing it, you can outsource it to an organization which can take care, which is a service provider, and which can take care of your disaster recovery and business continuity type of issues. So, these are benefits of having a cloud. Now, let us look at what are the basic opportunities that you get in cloud computing. So, there are, what are the opportunities? So, opportunities for whom? Opportunities for end consumers. What will the end consumer do? He gets the services done for which he pays some monthly rent, and for the business customers. So, business customers are those who sort of develop their entire business on the cloud. For example, if you are using Gmail, you are an end consumer. If I am actually using a call center on the cloud, then it is a business, I am a business customer. And then there are developers and independent software vendors who will develop for the cloud. So, there are 3 different people who can use this cloud, right. So, it can be an end consumer like Gmail, some fellow uses it. It can be a business customer who will write their software and their functionalities, either make you write in the as a SaaS, or you can they use the platform, or they use your hardware infrastructure and they build. And others are developers and independent software vendors, the ISVs, who will be developing on the cloud and giving that as an infrastructure and selling it as an software to others. Now, for an end consumer, he basically looks at software as a service, while a business consumer will look at both software, or all the 3, use the software, the platform and the infrastructure all as a service, while a developer or independent software vendor may use the PaaS and the IaaS. The IaaS is accessed through the platform. So, it is for a developer who wants to develop some application and put it on the cloud, which several people can access on the cloud and execute. He will basically look at the PaaS, and he will also try to access your infrastructure through this PaaS. So, PaaS through IaaS and IaaS through PaaS. The infrastructure will be accessed through the PaaS. So, there are a lot of opportunities when you look at cloud. The opportunities are for end consumers who need not invest lot of money and get all the data and services done at the cloud. The business customers are those who will use the cloud to its brim, while the developers and independent software vendors are those who will use the platform to develop applications for the cloud. Now, in the next session, we will go into security issues in cloud computing. Before I wind up this session, let me just sum up what we have done so far in terms of cloud computing. We have understood what are the characteristics of cloud computing, what are the deployment models of cloud computing, and what are the services that the cloud can give in terms of infrastructure, platform and software. Now, all these things are done for what? All these things are done because I do not want to take, I as an organization, I as an end consumer, I as a business partner, I do not want to no, there are 3 that we saw in the previous slide, the business customer, or I as a developer, leave the developers, at least the first 2, I as an end consumer and I as a business customer, I do not want to invest anything on the cloud. I do not want to know anything about it. I just want to use the service, and I just assume that my service will be properly done. Now, so in some sense you go and trust the customer, trust the cloud service provider, and you trust on what? You trust that he will give you the necessary service, he will give you the necessary data, and he will ensure the integrity of this data, etc. So, when I start looking at that trust, then comes the most important thing, what you call as the security. So, now we have seen so far all about clouds, all about the infrastructure and all about its deployment. Now we will go and address the major challenge in making people use the cloud, or really making it a trustworthy model for computation and storage and networking. The most important issue is going to be the security issue, and we will talk about the security issues in cloud computing in the next session.